there's a lot of mathematics involved in fishing. Fishermen or anglers that are proficient at fishing might use fish finders such as this one to locate schools of fish and have the greatest chance of catching fish. Fish finders are high-frequency sonar devices that locate schools of fish with the use of sound waves. The fish finders send the sound waves downward into the water and then receive the echoes that reflect off of the seafloor. When there is an object in the way of the sound waves, the fish finder will identify a difference in the sound waves, telling the sonar that there is an object in the way, such as a fish. When the sound wave signal is different, the sonar is then converted into a picture for the user to see where exactly the fish are located. Not only can fish finders locate other objects in the water, but they can also calculate the distance to the bottom of the seafloor depending on how fast the sound waves travel back. Fish finders relate to precalculus because with the use of sonar, they create polar graphs to calculate distances between the fish in the boat and locate the angle to different fish. Without using polar graphs, there would not be accurate readings for the fish finder. Dolphins and whales also use sonar by creating sound waves in the water that then bounce back and give the animals an idea about what is surrounding them. They use this to locate prey in the direction they are swimming in. Other animals that use some form of this are bats, but they use radar. The difference between sonar and radar is that sonar is sound waves underwater and radar is the use of sound waves above water. Since there has been so much research done on the use of sonar in dolphins and radar in bats, people are now finding ways to incorporate this into real-life applications and military purposes. One military purpose would be submarines, which also use sonar. Math is important to understanding the sonar that dolphins use because when the dolphins emit the clicking sounds on the water, sound waves are created. When the sound waves are created, they resemble a polar graph, creating circles around the dolphin, and the object that is first hit by the sound waves becomes a point on the polar graph. This use of math helps researchers create new devices that resemble the sonar that dolphins give off by using polar.
This is a picture of a fish finder graph with 3 fish located on it. You can tell the location of the 3 fish because the unit circle is superimposed. The location of the first fish on the graph is 4 pi over 3. You can tell that this is a location because the radius is 4 and the first angle is pi over 3. The second fish is located on the radius 1 and located at angle 5 pi over 6. The location of the third fish is on radius 3 and is located on angle 5 pi over 3. This is how you find the location of the fish using the polar coordinates. Next, we are showing how to convert the polar coordinates that we found on the fish finder to rectangular coordinates. We use the equations x equals r cosine theta and y equals r sine theta to find the rectangular coordinates. For the first equation, we plugged in 4 for the r and we plugged in pi over 3 for the theta. We then found that cosine pi over 3 equals 1/2, so 4 times 1/2 will equal 2. For the y, we then plugged in 4 as the r and sine pi over 3 for the theta. We then found that y equals 2 root 3. For the second equation, we plugged in r as 1 and theta as 5 pi over 6. That then came out to be x equals negative root 3 over 2. For y, we plugged in 1 as r and theta as 5 pi over 6. We then found out that y equals 1/2. For the third fish finder location, x equals 3 cosine 5 pi over 3. Which then turns out to be x equals 3 1/2, which equals 3 over 2. For y, r equals 3 sine 5 pi over 3, which then turns out to equal 3 times negative root 3 over 2, which is equivalent to negative 3 root 3 over 2. So that is how you find the coordinates for the fish finder graph.
From us, like me, Hannah, Lauren, we did the first people that did the.
Catch of the day.
What is it?
It's a lily. It's a lily. You tell it's a lily by the way it is.